So we look at similar triangles, and again, guys, this is basically going to be 2 lessons we're going to do. And then on Monday, we're going to start our right triangles unit. So right now, basically what we're going to be looking at today is determining if 2 triangles are similar. And there are basically 3 ways of doing that. And then we're going to be using proportions. And I think for a lot of you guys, as you're trying to do this, you're going to struggle mostly with writing the correct proportion. If you don't start out with the correct proportion, nothing else matters. So that is going to be the most important part of your homework assignment, as well as the assessment. So we look into this. There were basically 3 ways to show that 2 triangles were similar. What does the AA mean?
Your angles are similar.
Angle, right? So as long as we had 2 angles that are similar, or that are the same, that means that our 2 triangles must be similar. So think about angle. Let's clearly that we have 1 angle that's equal, and then we have another angle that's equal.
Did you have angle?
Well, let me ask you this, Bree. That's a great question. What if we have angle?
I get it. 2 angles are the same. They're not.
Must be the same.
Okay.
Yes.
Oh,
Okay.
ask it.
And that's not something I actually taught you guys, and that's probably why, because to me, I think it's kind of common sense if you stop to think about it just like you did there, Bree.
Yeah.
It's called the third angle theorem. And if you have 2 triangles that have 2 angles that are the same, then the third angles must be the same. Again, I think it's kind of a common sense thing. Okay, then we have side, side, side. And what this means, again, I guess I want to back up a little bit here. What is true about similar triangles? What did you guys learn from your research? Jackson?
Same shape, different size.
Same shape, different size. So what does that tell you about your corresponding sides? So they're going to be different length, but what about their ratios? The same ratio. Okay, so we say that side, 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 what we're talking about is that the 3 sides are all proportional. So the length of BC to EF is equal to the length of AB to DE, which is equal to DF, no, we'll screw that up, DC over DF. And I did screw that up.
Yeah. Yeah.
That should be
It's
AC. So again, guys, remember when I talked about, right as we were starting this lesson, if you don't get the proportions set up right, nothing else matters. There's some simple things to kind of keep in mind. Notice that the way that all 3 of these are set up, which triangle is on top on each one of these portions? The small. And so if you kind of remember that however you set up the first proportion is exactly how you need to set up the next proportion. And so in this example, we have the small over the big. And as long as you keep doing that, you should come out just fine for your proportions. So side, 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 basically if all 3 pairs of my sides are proportional, then they are similar. But now the problem is you actually have to know all 3 sides. That's the downside. The next way is side angle side. Again, where's our angle at? What's side angle side?
C.
Well, if we're looking at SAS, where's my angle at? Chris? Yeah, what do we call that angle when it's between 2 things? You remember the term we use for that?
Point.
Starts with an I. That's when we talk about triangle congruence. Jackson? Not inclusive, but included. Okay, so it's the included angle. So when we look at angle A and D as being congruent, then what must be true about my sides? No. with similarity, they're not the same, they have to be, what's the key word? Proportional. And they have to be proportional. So therefore the ratio of AB to DE, so there's one pair of my sides, right? That ratio has to be the same as what other ratio? AC to DF. Now this SAS only works if the angle is included. Okay, so it can't just be any one of the random three angles. It has to be the included angle between the two sides. All right, any questions so far on the different ways to show similarity? Okay, so the first part of our notes, again, we're going to be looking at this and we're going to say, yes, the two triangles are similar. No, they're not similar. So here we go. Okay, let's practice writing our proportions. The ratio of AB to BC. DE to what?
DE over
Yes. So that's going to be DE over EF. What about AC to DF? So AB over DE. Is there another way I could write that?
BC to EF.
BC to EF. How are we feeling with writing these proportions?
You got it.